technical issues. And so for today, I want to finish up the Python basics, and I already posted lab 5 yesterday. So because next week is spring break, so you'll be due after the break. So it'll be 2 weeks from today, and hopefully you have enough time and then you can enjoy your break next week. And but if you need more time, let me know. So lab 5 covers what we talk about on Tuesday, and also something today. So about dictionary, functions, classes, and file handling. So again, today I think it's the building blocks for your packages, because your package is going to contain functions, classes, and deal with file, opening file, something like that. So this is very important. And if we don't have time to cover them all, make sure that you read the documents, read the notebooks, and then practice. You also have examples in the lab assignment for you to practice this. But this is very important. So I want to really highlight today is to have your building blocks so you know how you can design your packages, because eventually you're going to compose of functions. Our package most likely will be just functions. And we have been using functions since the beginning of this semester. You are calling like print function, you're using the title, upper, lower, those are all functions. And we're also going to talk about class, how you create a class. Okay, so lab 5 already posted. Again, let me know if you have any questions. So the submission is very similar to lab 4. I just need Jupyter notebook, and then you should have a base that allow me to open in Google Colab, so that if I need to execute your code, I can do that. So make sure that you pay attention to lab 4 and lab 5. If you don't have that icon, I will take points off. Okay. So next, let's go back to the examples here. And so we're going to talk about number 8, functions. So let me open this one here. And function is defined by the keyword called def. So if you want to define a function in Python, it's go like this. And it's a function is a code block. So you need to have colon at the end. So define and then the name. So this will be the name of your function. And then within there, you can indent the code and then have something in there. We also going to have the documentation. So for now, you don't really have to do that. So documentation is important when you are trying to build your package. So let me show you an example. Let's go to like leaf map. And so leaf map on the left side here, you should be able to see like API reference. So this is basically called module. Python has all kind of modules. And then within the module, we're going to have functions. So let me show you, for example, let me click like common. And then on the right here, you're going to see a bunch of those functions. So let me click this one here, download file, right? For example, I created this function that allow you to download all kind of files from the internet. So just passing URL, and then you can use to download files. And if you scroll down, you should be able to see this one here, source code, right? So you should be able to see all kind of source code here. And this is what I was talking about. So this is called docstring. We'll talk about it later in a couple of weeks when we're designing your package, building the functions. But this is super important, because at the eventually when you build your package, you want to tell the user what to provide. So these parameters, if you go back up here, is this table is coming from. So I don't manually build this markdown table. It's all built automatically based on the source code, based on the docstring. It's automatically built based on this one. So that's why very, very important that later on, when you design a function, you want to provide this. But today we don't have time to cover that, but I just want to let you know this is why we want to do that, so that you can have this. So when people go to your website, or you pretty much right now, if you go online to find any packages, it's going to have the so-called API reference. So basically you can read the documentation and read what is you want to provide. Whoops. And what data type, a description, and any default value, something like that. So it's super convenient. And under that, you will see here, right, you have all the source code, so you can have as hundreds of lines of code if you need it. And this will be the function definition. So everything will be def, and then the name of the function, and then within there you can have parameters, and the parameter can be you can have required parameters, you can have optional parameters. So this is what we're going to cover here, right? Just like this one here, right now it doesn't have anything. And then you're just going to print out hello. So when you try to call the function, you'll be just the name and then parentheses. So make sure that you put the parentheses, otherwise it's not going to work. So if I write this one here, you see print out. But if you don't have the parentheses, it was just going to say that it's a function. So there's no content. So function is a definition, and it's why Python you can use programming to repeatedly doing things for you, because you can design a function and then you don't have to write code many times, so you can reuse the code, right? So think about here, when you call the title, upper, lower, those might look pretty simple, but you can combine a couple of functions together and then to do a lot of things. Okay, so in there, this is where you can write things to ask Python to do it for you. So function name, building blocks like that. And so this one here doesn't have any parameter, or you can just parentheses, that's done. But in here, you can actually define a so-called parameter. So this one is the parameter that you use to pass into your code. Okay, so this is just a tag. We can think about this just a identifier or placeholder, and you can replace that one with anything. So the name here doesn't really matter, but usually we want to choose a name that's descriptive and is useful, but you can choose whatever variable name you like, but make sure that you use the same one. So here, what this one is essentially doing, okay, you give me a username, and then I say hello username.title. So basically, we're going to print out the title case. So you look at here, and when you are calling the function, you type the name of the function, and then you pass in this argument. So this argument here is going to basically replace whatever this one here replace with title case, right? So this is how you call the function. Just like, for example, you previously we called, for example, replacement or remove or pop, right? Remember? So like when we call a dictionary or whatever, when you apply function, you can provide this parameter. So this is the parameter, and you can design your function to accept as many parameters as you want, right? So just like in here, how many? Like more than 10 parameters. And then within your source code, you can ask Python to do something based on what is provided. So this is a very simple function, just one argument. And sometimes you can also like have multiple, but you need to make sure that when you are calling the function, the parameters must be in order. So when I call this function, the first parameter, the second parameter, it needs to be the same parameter as your function definition, because your function definition, you have two parameters in here. When you're calling the function, you need to have exactly the same thing. So you will see here inside the function, you have two lines, right? If you're trying to print out, for example, you do the same thing. If you're trying to change to something else without a function, you need to rewrite your code. You need to print, for example, assume this function is trying to print out something, and then let's say I want to do that 10 times, right? Then you will need to write this print function. Depends on how many lines you have in here, you need to write 2 multiplied by 20. So you need to write the print line 40 times. It doesn't really make sense. And if you have like print that 10 lines in there, multiply by how many times you want to do that, it becomes very overwhelming. So that's why we want to use function to basically simplify and reuse your source code. So function, parameters, arguments, these are the things that is very important. So right now, these are all required. So you see here, we define a function and then provide two parameters in here. Make sure that your function, when you call the function, you need to provide exactly the same number. The order sometimes doesn't matter, but you need to be careful. Whatever you put in there, in order, in sequence, and also the same number. Because if you don't, it's going to change the result. So here, if I change to something else, right, it's going to just change the first one. And I can do something here. It's going to change the second one. So if you reverse it, oh, the allergy is driving me crazy. Okay, so here, now you change the first one. So make sure that the order matters. Okay, so it depends on the name. But sometimes if you really want to, like, because when you have the too many arguments, sometimes it can be challenging, because if you go back to this function here, right, I have 10, like more than 10 parameters. So when users trying to call the function, you basically, if you all require, then you ask the user to enter 10 parameters. Sometimes it's just too much. You can have some required, have some optional. So in that way, you don't have to provide. If the user wants, they can, but you can provide some so-called default values for your parameters. So that's usually the best practice is to minimize what the user need to enter. So you only ask the user to enter what is required, and then you can have something optional. So here, the order matters. We already talked about this one. So this is essentially what this one. You can still have 2 required arguments, but when you are calling the function, you can type in the parameter name. So in this case, the order doesn't matter. As long as you provide 2 of them and you have all of them covered, then you are good to go, right? So this is how so usually when you are calling a function, if it is required, then you usually don't have to enter the parameter name. So think about if I have 10 parameters, you're going to have something equal to something, something equal to something, comma, something equal to something. So it can become very, very lengthy. So if it is just required, for example, only a couple of those at the beginning, you don't actually have to do this. So I can just type this one, for example, remove this one and remove this one. But make sure you in order. So what value you provide here, this one is going to this one, go to this one, go to this one, and then it's going to replace the value. So, but if you want to change the order, then you can provide the parameter name. So in that way, you can, it doesn't, for example, animal type, you can have the pet name first. So like this. All right, the results should be the same. So if you basically, if you provide the argument name, the order doesn't matter. If you don't provide, it's going to use the sequence appear in the function definition. So this is how you call the function like this. So this to be the same. So next one, default values. Just like I mentioned earlier, if you don't really need to require the user to enter, you can just specify a default values. So in here, right, you have 1 parameters, and the second one by default you assume that it's a dog, a cat, or whatever you like. So or I can design a database or a function, and I can assume that, okay, if you are taking this class, by default you are a geography major. I can do that because the majority of them come from the department. But you can also call the function that allow the user to provide what major, what department they are from, right? So in here we will say DEPT. So just, for example, give me your name, and then your DEPT department name equal to something, right? So this is what you can, my name is, and I'm from like what department. Makes sense? So I can show you here, for example, I can have a function like this, DEF, I can say student, and then I can say name. Okay, I can also say DPT. By default, if you do it like this, I can say print out and then F. Okay, so again, this is F string, and so okay, so my name is blah blah. Okay, and I'm from the whatever department, right? Easy, right? You can have many lines, but oops, empty. Oh, from DEPT. Okay. What? Have my name. Oh, why I have all them here? It's what now, right? So and then I can just call here, right? So you can call the function, and then you can just provide the name. So for example, my name is Robbie, okay, and I am from geography. Oh, you don't have to provide. I can just provide just one, right? So you'll be here like this. Missing. Oh, it's required. So that's why I need to put in here. So now I can say geography. Right? Make sense? So here, I can provide a default. For example, I can say geography. So now I don't have to provide this one. You can, but it's not required. So if you don't provide, it's going to use the default value that you provide. So if you have something equal to something in your function definition, you be still the missing one position argument. Interesting. So name, this is a bit weird. DPT. Yeah, I think this one should be optional. This is weird. Oh, because earlier if you change something, you need to rerun it. Otherwise, the function definition is the previous one. So here, right? So now I only provide the name. I don't even have to provide this one. It should work just fine, right? And if you need to customize that, I think okay. Here I say forestry. Okay. Make sense? So you based on the order, so you can provide. You don't need to do like any like parameters, but the reason for this, sometimes you want to have the argument name because you might have multiple parameters and you only want to like you only want to provide one. So here, let me show you another one. So I can say state equal to Tennessee. And so right now when I'm calling this function and from 0 to and I am from which state, okay? So think about here. If I run this one, right? I'm from Tennessee. So now I have two optional arguments, optional parameters. And assume that right now I want to change to another one. So I say Robbie and I'm from New York. Right? So what should I be doing here? State equal right New York, right? In here. So you see I didn't provide the second one. I didn't provide the geography because when you have like more than 10, sometimes you only care about one, then you just provide the name. But can I remove this one? Click like this. Will it work? Why not? Yeah. So if you don't provide the argument name, it's going to is the sequence, just like in the order. So you're going to treat this one as the second one. So this is you want to get some unexpected results. So make sure that if you have the argument, the required one, usually you don't have to enter name. So I don't usually need to like name equal to this one. Oops. And then, for example, DPT equal to this one. Of course you can. It's made readable, but usually you don't want to make the line very long. So if you think about this function here, like have more than 10, you don't want to list them all because you only provide the one required, and then to make your source code concise. So if you only like maybe just provide one parameter, you just passing, you don't really have to specify the name unless you are providing something like not in sequence. Then usually this is where you want to provide the name in here, just like this one, right? So I can do it here, DPT. Once you provide the name, keep it in mind here. Also in this function definition, required parameters comes first, optional comes after. Once you have some optional, everything else come after that have to be optional. So you cannot do it like this, my name and then my what else? my name and my major, for example, right? You cannot do this. If something is already have an equal sign somewhere, the next one you put in there cannot be a require. If you want to do that, you better move this one to somewhere here. And this is fine, okay? So require comes first and then optional comes after. So now if I have this, then this function certainly won't work because you need a minimum of 2 parameters. So I can say measure, and then so in here, what I can do simply just say Robbie, okay? And then you need to provide the second argument. So I can say GS, right? And take a look. Oh, because I haven't provided here, and I will say I am measure in, okay. So this should be just like that, and run again. Right, measuring GIS and my department, blah blah blah. Okay, so optional, require, and also the position, they all matters. So if you really want to do this, make sure the first 2 arguments, you follow the order, provide them in sequence, and then after that, you don't have to. So I can say DPT equal to California, right? Oh, no California, so it'll be state. So this is how you can call a function, depends on the argument. And yeah, so whether you want to do that or not, by this like good practice, require parameters, usually you don't really have to specify unless you have way too many and people have no idea. If you only have 1 or 2, you can just skip the name of the argument, just provide a value, and that should be fine. So next one, how do we return the value? So previously we only like print out something. That's not very useful. Most of the functions or the packages you want to do is going to return something. So basically, when you use that to do some processing, after that you want to get some result. Okay, so for example, I can create a function and try to calculate your GPA, what your letter grade you're going to get at the end of the semester, right? And then I can take all your assignments, all the grade from the assignment, from the exam, from the quizzes, and then I try to calculate it, the total, and then I give you a letter grade. So if you give me a bunch of grades, I'm going to return a letter grade to you. Just one value, right? So this is one you can do. Or you can just, for example, you can create a checkout system. And then so the user can buy a bunch of stuff. You're going to return a value. How much does it cost? Okay, pretty simple, but this is how you can return a value. So inside the function, the return value is going to here, and keep in mind this usually should be the last line of your function, because once something is returned, all the codes beneath won't be executed because it's going to return. Basically, it stops your function. But in some cases you might have some return, like in there you can have if else, if equal to something I return this one, else I do something else I return the other one. You can do that, but usually you will see like the function usually a return argument will be at the end of the function. So if we show you some example here, right, blah 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 blah, and you see at the end you will see a return, for example, filter date, and if you scroll down, it's going to do blah 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 blah, and at the end it's going to return something. Pretty much they're all very similar, right? GDF to DF, and scroll up, do something, if something, something, do something, and then return something. So return is very important. If you're doing a function, usually you're not just printing out stuff. You want to actually get something out of that. Just like when you doc title, doc upper, doc lower, it's actually return something back to you, and then you can use it later for other processing. So here, right? So if you give him the first name and the last name, I'm going to put it and then combine together to give you a full name, and then just going to return the full name title. So return, pretty simple in here, right? And once if you have a return argument, then you can assign something to a variable. If it doesn't return anything, you cannot. It's going to be empty. It's going to be none. So take a look at this one, right? Let me comment out this line here. And will you get any error? Can I run this code block? What does this one really do? Let me run this one. You see, none. The reason for that is because you don't return anything. So if you have a function, you do a bunch of stuff in there, and then you never return anything, then it's useless. The function, you cannot access the content you do inside the function. So always remember, if you define something, have a return argument, return something at the end. Otherwise, because you can do whatever you want, and then you're going to execute a full name, and then you're going to come out. So it doesn't really do anything. So if you try to assign this one, because it doesn't return, by default it's going to be none. So you don't return anything. So if you try to print out, it's nothing. So make sure you return something in here. And the other thing I want to point out here, very important, okay, pay attention. All the variables you define in your function is only valid within the function. So it's not, once you execute the function, it's done. Once you get out, the variable name is not available. So here, you can think about, I get formatted, I have the name, and this name here, this variable, first name and last name, these two variable is only alive within this code block. And once you get out, it's gone. So if although I can execute this one, right, everything works fine. But if I'm trying to print out, for example, print first name, you see it's not defined. So function definition, although if you provide a list, you will be able to modify the list. But for most of byte values, if it is a string, if it is the value, a number, it cannot be accessed down here. So even though, for example, I can have a last name equal to, let's say, by default, if you don't provide the last name, I'm going to have the last name, for example, called Brown. Okay, I don't provide it. And if I execute this one, right? Let me delete this one. Okay, I call this one Jimmy Brown. And so now you see, okay, I'm trying to print out the last name. Will it work? Yes or no? Will it work? What's the logic? Right? I have the last name here by default equal to Brown. Looks like it must be somewhere there. So if you're trying to execute, take a look. No. Anything, all the functions, all the values for the variables, for arguments, they are only within the function. Once you get out, you cannot access the value. You cannot access the variable name. It's destroyed after you execute the function. So we execute this function, and so basically when Python, also by the way, when Python is executing here, this line here doesn't really get executed. So if you have something wrong within your function, Python will not know until it's executing function. So otherwise, it's just going to read the definition. So think about here, I'm defining this function, and then within here, I can maybe, let's say, A equal to B. Okay, I just made it up. And can I run this one? Will you get any error? Oh, let me ask you this, comment out this too. Take a look at here. What? Why there's no error? DEF get formatted name, first name, last name, blah blah, A equal to B. Apparently A and B that is not available. So if I just type in here A, it's not working. B, there's no variable name A and B. It's not also in the arguments. So this one is wrong. But when I execute this code block, it doesn't catch the error. Why? As I said, when Python trying to run the function, it only checks the name. It doesn't check anything else within the function until it's being called, until this function is being called. So just like what I talked about in the past, if else, like within there, it doesn't really check it until it's being executed. So in this case, this line is never checked. So that's why even if you have errors, Python doesn't know, because I'm only execute this one and then I'm out. I just check the definition, see if this valid. But if I call this function, now it becomes a problem, because when you call this function, it's going to go to this function again, and it's going to check the line line by line. So in that way, you're going to catch the error. So now if I run this one, it's going to say here A and B, name B is not defined. Okay, so very important. Functions sometimes might have errors, but Python might not catch it until it's really being executed. So, and you can also return multiple values. It doesn't have to return just one. You can certainly return multiple values if you want to. And so for example, you can return a dictionary. Okay, so I have a function, I have first name, last name, and then I can construct a dictionary based on the user input, and then I return a dictionary. So here, right, what you return. So basically, a Python function can return anything, and really anything. So it doesn't really matter what you put in there. It's going to be return something. And second, okay, you can also pass in a list. So you can return a list. So for example, I can provide a list of names, and then I can greeting all of them. So here, I provide a list, and then within the list, it's going to do something. For example, print for everyone. So this one doesn't return anything. So just print it out. That's fine. But you can also return a list. You can return a subset of the list, or you can return a name that contains a certain character, or you can return a list that contains some number or whatever. Okay, so I can do it like this. For example, I want to find out DEF and students, select students. Okay, and so here I can just allow the user to provide a list of names. So for example, I can say names, and then I can try to find out, for example, you just give your name, and I'm going to tell you if your name is like less than 6 characters or not, right? If it's 6 characters, you're going to be selected. If it's more than 6, you're out. Your name is too long, okay? So how should we doing here? I'll give you a list of names, for example, of the names here in this class, and you tell me whose first names are less than 6 characters. Can we do something like that? How do we define the function? Anyone? This is the easy task. After this today, you should be able to do that. So keep in mind, when you assign a question, you need to come think in mind, how do I think about that? Give me this name, and you should think about, I don't care about how many names you give me. It's just a for loop. It's just loop. So you should think about, how do I do that for one, right? So if I give you a string, can you tell me, is it more or less than 6 characters? How do you check the length of the string? LEM, right? It's that simple. So what you really do, you can do it. If you give me something, I return something, yes or no, or I can pass into something. So I can, for example, to me, I just simply like result equal to an empty list, and I'm just loop through them for name in names. Okay, if LAN name, okay, less or equal than 6, and then I'm just going to result append name. That's it. As simple as that. You give me something, I tell you whether it's less than 6 characters or not, and then I push this one. Push this one to the empty list. So this will be the result, and then after that, as simple as this, I'm just going to return the list. So make sure within the for loop I do something, I'm done, and then I just return result. Okay, that's it. So this is a simple function they can do, and then now I can just call the function and it can provide whatever name. So I can say select students and then parentheses. Within here I can have square brackets, and this is just you provide, right? And then I say A, B, C. Okay. 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 And maybe another one. Whatever name. Alright. So I can provide whatever, and the result is going to return just 2. Alright. Think about it. That is very, very powerful. So make sure that if you're asked to do something, don't feel intimidating. Think about how I can do it. For one, Python is good for looping, good at looping. If you can figure out one task, it doesn't matter how many you are given. It's just like a loop, a while loop, or for loop, or anything like that. So next I can provide, like, it doesn't matter how many you provide to me. It doesn't care. I can change it. I can do something. If they are all invalid, you're just going to get an empty list because none of them meet the requirement. Questions? Alright, not so difficult. So simple, and they can modify the list if you need it, and you can like look at example. So if you provide a list, make sure that you don't accidentally make changes to the list. Otherwise, when you get returned, because list in Python is called by reference. By reference, that means if you're changing something to the list, when you come out, the value will be changed. If it is a value, if it is a string, the value will be the same. It's not being changed. So list and dictionary, those are data types that you need to pay attention to. So the next couple here, I want to show you this one. I think this is the most common one that you're going to find in Python when you are defining a function. So you can allow the user to provide as many arguments as needed, but sometimes it is too many. You just have 2 stars. Okay. The other one here, I don't really want to cover that because it's not very commonly used. And this one, you definitely need to understand what this one is doing here. I define a function, and then I have 2 arguments here, 2 parameters, the first one and the second one, and then I have 2 star, and then just another name. So this is basically a dictionary. So 2 star means you're going to unwrap the dictionary. So I can provide as many arguments. In that way, I don't care like how many. You only provide 2, and you can provide as many as you want. So if you go back to, let me see if I can show you some functions in here. Download NED. Filter bounds. Yeah, just like in here. So if you go online, most likely you want to find some function looks like that. So you're going to have a name. So require, optional, and usually you will see this one, star KWARGS. So KWARGS, so just like a convention. So if you want to design a function, you want to have some required parameters, and then you want to have something at the end. That means you can provide anything, but you need to be something equal to something. So this one later on is going to pass to some other function. For example, here, GeoPandas can read the file. You just pass in the first parameter, and you can pass as many as you want. So let me go back to this example just to show you what this is doing. So I have the first name, last name, and then I have another one here, user info. So you will see here, right? When I try to call the function, I have the first name, I have the last name, I can provide the location, I can provide anything. So here, look at this one. So when it's returned, it's going to return the dictionary. So you return the first name, last name, plus whatever you add to there. So here, I can also maybe write another one here. It doesn't really matter. So the name doesn't have to exist. And I can do another one here. I can say, okay, department, for example, equal to geography. You see, it's just going to get it. Or I can also provide another one and say major equal to, oops. By default, by the way, so the parameter don't have to be a string, and then you can say GIS. See it? So you can provide as many app loads. It doesn't matter. So this makes it very flexible because sometimes you have no idea what kind of information the user want to enter. So this is kind of like, they say you set up a Google form. You're trying to collect information and they need to enter the first name, last name, those are required. But you can allow them to like enter whatever information they want to provide, additional nodes or something like that. So this is very common in Python. But make sure that inside your function, you want to utilize the information that the user provide. Again, you can check out some of the functions examples in here, see how it's being used, right? So require, optional, and then I don't care what else you provide as long as that function parameter is supported by some other functions. So because GeoPandas, for example, read file, it has a lot of functions, and sometimes you just don't want to spell them all out. In this way, you will use ** KWARGS, and in that way, your function can accept many parameters. Okay, so it won't run into any errors. Otherwise, without this one here, pay attention, right? Can I do this? I remove it because if you see here, user info, and then you cannot remove it, but because it's being used later on here, so you will use it most likely with KWARGS, and then it's going to be used later on. But I can also do it like here. If I do another one, a better way will be like this. So you'll be DPT, okay, and then you say geography, comma, and then you'll be KWARGS. Okay, so this is usually the common practice, and keep in mind here, when you're doing the KWARGS, it's a dictionary. Again, it's a dictionary. Dictionary is like you have a key, you have value, you have a key, you have a value. So by default, this one is just empty. You will see, right, empty the dictionary, and then have the key, and then assign to this one, have a dictionary, have a key, assign to this value, and then return this one. Because when I call this function, what this one is really doing is going to grab, I think you need to have the DPT here, and then do it this way. So when it's calling this function, it's going to grab all these values, and then like 1, 2, 3. So these 3 parameters, this 3 here is going to follow this one, and then the other 3 here is going to be constructed as a dictionary. So you have a key, you have a value, and then basically, let me print out this one first, just to show you like what it looks like. So KWARGS. Okay, here comma. Where? Oh, okay. So here, so it'll be like this. And let me remove this one. So take a look here. I provide this name, function arguments, and then right KWARGS. You will see here these 3 arguments, these 3 pairs of keys and values are being converted to a dictionary. So this is what this one is printed out here in the first line. And then I can add another key, and then return it. You will see now I have this complete information. Okay, so this is why sometimes you want to do this, because you want the user to enter whatever they want, as long as it's a dictionary. So a key, a value, and key, a value. Okay, so this is how functions work. Essentially, you have a name, you have arguments, optional, you have require, or you can have arbitrary arguments. So basically allow user to enter whatever they want, and then inside there you can utilize the user how many users enter, what kind of information being utilized, and then you return the value back to the user. Whatever you return, you can decide what you want to return. You can do something, you can reduce, you can add more, you can do some calculation, you can do a bunch of things within the function. So it's the building block of Python packages. So next one is about classes. Looks like we are a little bit behind. So classes is also very important. For example, when you're trying to create a map, right? Leaf map, dot map. So that map is a class. That class can inherit from something else. So in Python, class is defined using the keyword class, all lowercase, and then the name. And then from here, you're going to do inside the function, inside the class. You will find this function name. So def underscore init underscore, and then it's going to be self, name, and age. Okay, self is a keyword. Okay, usually you can think about a class is just like abstraction. It's like a model, and then when you're trying to create something based on a model, it becomes an object. Okay, so in Python, class and object are very two important concepts. Class basically you can think about just like a blueprint to do something, but it doesn't exist yet. It's just like a model, and then when you're trying to create one, then you can create an object. Just like a car, you have a design, you know like what a car looks like, what components or things in there inside a car, but you actually don't produce the car until you actually produce it. Okay, so this is a class. Also it's just like a definition. It's like a blueprint, and then I can use it to create. So let's just look at this one here. Right, so when it's creating, it's going to call this function. So underscore, and then the self, you always need to provide self. Self means you are doing that, you create an object, and then this is the variable name, and then this is called attribute. Something dot something, self dot, basically, okay, I'm gonna create a dog, and then I'm gonna give you a name, I'm gonna give you an age, and you can also have functions. So this is usually called method. We don't usually call function. Function means it's independent. You don't rely on anything. But if it's a class, within the class you can define a function, then it becomes a method. Or you can also have attribute. So class has two, usually attributes just like what it has. Method is that what kind of things it can do. And so here I have two, right? I can sit, I can roll over, and then within here I'm just going to print out something simply. So all the classes in Python, you're going to have a function like this at the beginning. def, so this is the function when you construct that object based on that class. This is the function going to be called. And other methods, you can provide what it have, and then later on, if you need to use it, you can do it, right? So look at this one. So now I can create an object based on that class. So also by the way, so class in Python, usually you're going to use title case. So you're going to name your class as the first character uppercase. Unlike functions and variables and others, usually we're all using lowercase only. Class is the only exception that you want to define your name, and then you're going to have something like this, do.dog. Okay, don't do this. Don't define the class name like this. It's not the convention. So you should have the title case or camel case. It's better. Okay, so it will be like this, and then I create, for example, here. When you create this object, this is the parameter you need to provide. Okay, name and age, right? So when I create this one, I call this one here, and then I provide the name and provide the age. And take a look. My dog's name is Willie. My dog is 6 years old. Right. So once you create, yes.
Go back up to the init function.
Mm-hmm.
Can you make one of those to accept a different list of arguments?
Oh, you mean here?
Yeah. So can I have one that just does self and name and everything? So you can have one for init and one class.
I'm not quite sure. So you mean you want to create something, but you want to provide different number of arguments?
Yeah. So like if the user gave just a name, and
Yeah, you can. So here you will just provide, for example, age, but still you need to, if you want to provide different argument, it depends on what you want. So for this case, if you have, I can just provide those default argument one way, and then you can do it like this way, just like what we used earlier. In this way, it becomes flexible, so I can provide many parameters. So let me do this one more time here, and then I run this one, right? I don't have to provide this one. By default, it's going to be 1, and I don't have to provide the age because the age is only by default. I can have another one. For example, I'm let's say my owner, okay, equal to Matt. Okay, makes sense. This is not going to do anything. It's inside your parameter, so it's inside your something. So here you can certainly if you assign something, for example, but it needs to be exist. Right now it doesn't exist yet. So this has many arguments in there. But inside your function, inside your class, you can access that one. So I can say if let's say here owner in KWARGS, I can print out something, like start doing something extra. So here I can say my owner is, and then create brackets and can KWARGS owner. Oh, you need to have maybe double quotes. So think about this one here. You allow the user to provide additional arguments, but you only use it when it's provided. Okay, so in this way, right now, if I run this code here, I don't provide this one, right? Just the name, and it's going to use the default parameters. It doesn't show you like what's the owner, but when I provide this one, say again, okay, owner equal to Jack. Okay, you see now it KW. Oh, you don't put this one inside. It needs to be F string, so you get the value. So now if I run this one again, come here, see that? So this is how you can make things very, very flexible. So just like a leaf map, I can show you here. If you go to leaf map and then maybe leaf map module, you want to find the leaf map map class. So we go to the map class, and then inside here, if you look at the function like this, I don't even provide anything. I just init a cell, and then you can provide whatever arguments. And later inside your code, I'm going to check your arguments. Whether your argument contains specific information, then I can do something. So you create a map, for example, map equal to leaf map.map. I don't need to provide anything. By default, you're going to use the default parameter. But you can provide a center, a zoom level. So let me show you like this case in here. Right, import leaf map. Right, and you can say m equal to leaf map.map, and then just print out the map. You see, I don't provide anything. It's going to be, it's going to just create the default map in here. So nothing fancy. But now I can do something else. I can say m2 equal to leaf map.map, and they say I want to center the map. I can just center, and then say maybe 40, and then negative 100, and I also want the zoom level equal to 4. So take a look. Oh, I need to print out the map, so I need to print out the m2. Take a look. So now my map is based zooming in here, and you can also say, okay, I don't want this toolbar control. You can disable it. I can say toolbar, I forgot the name, maybe CTRL equal to false. Maybe full name. You see, it's gone. So that means my class, I allow the user to customize it. So if you don't provide, I create a default one, and if you provide, I'm going to check your parameters. So you can read this argument here, see how I do that, right? I can set a kind of attributes, and then you're going to say, okay, if, for example, height is in the arguments, I can change the height. So here, for example, this one, right? By default, if it doesn't specify, by default, I'm going to use the height 600 pixels. But if you want it smaller, I can do it like this way. I can say height equal to 300 pixels. So take a look. It's going to be much narrower. So this is how the functions classes that makes it flexible. Then you can use that arguments. Make sense? So here, as I already showed you, you can make it very, very flexible. But all the functions you want to have init underscore init underscore parentheses and then self comma. You don't have to provide parameters if you don't want to, but at least you want to have a self just to represent it. I'm going to create this object, and once you have that, you can access the attribute. So here, for example, I can sit, I can roll over, and this is where your object becomes useful, because you can type my dot, and then hit tab. This is where it shows up inside your function. So your function have something, this is where it's going to comes up. So it's going to show you here on the green, the orange color is the attribute. The F, that means it's the function, right? So if you come back to here, my class, I have these two attributes, self dot something. I also have two functions, right? So this is where it comes up. If I add more, it will come up. So here I can also say self. If I want to, I can self dot, or maybe like this. So if owner in blah 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 blah, I can say self dot owner equal to this one, kwargs owner. Make sense? So that means if you create an object, if you set the owner, you only have an additional attribute. So let me write this one more time here, and let's execute this one. If I don't provide this, so now if I my doc, okay, hit tab, you see I only have 3 attributes, because when you construct this object, it's going to read your arguments and then construct the attribute based on your condition. So now if I provide this one here, owner equal to that, okay, so run this one again, and now if I hit tab, see that now I have an owner. So this is how you can design what attribute you want to have. Just like earlier for the map in here, right? I create this map, and then you can see m dot hit tab. You're going to have it's not working. You're going to have a long list of functions, right? So functions, attributes. Where does that come from? It all comes from your class, how I define. So if you on the documentation here, you can see I have a map. I can have base map. I can do a bunch of things. So this is where, if you design your class to have these functions, then when user use your class to create an object, that object will inherit all the attributes and functions that you create for them. Think about you're an engineer major. You design something, your robots to be able to do something. Then your robot, you can have like weight, height, name, attribute. You can also like robot can walk, can jump, can do something. So this is all programmed within the class. So the class is just a building blueprint. It doesn't do really anything until you create it. And you can create as many instances. So this is something called instantiation, like instance. So a class can be used to create so many instances. So, and then within the instance, it's going to inherit all the methods, all the attributes of that. Okay, so pay attention. This is, we're going to talk about more later when you try to create your package. Your package right now has nothing in there, but you can create a class. You can create multiple classes. It doesn't have to be one. You can have many classes within your package. And then, just like, let's say I build a class called engine, okay, and I can build BMW, I can build Tesla, I can build anything else. So you can have that, and you can inherit from other classes. So this is how you can access the attribute. You can create the instance, right? The same thing here, like a car, initialize, and then have make, model, year, and then within there, I assign the attribute. If you don't assign, you won't have the attribute. So make sure that if you ask the user to provide some parameters, you might want to create something and then assign to itself. Otherwise, it's not being returned. So the information being passed in the user passed to the class is not being utilized. So make sure that you somehow, if you use some of these parameters here, you want to use it somehow, somewhere in here. Once you have the attribute, later on, inside your function, you can access the attribute. Otherwise, the information is not being passed through. So it's use this. Okay, so you see here, right? Blah, 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 the name, the self, and now I can actually access the function, the attribute. Year, make, model. So you see here, within this function, I don't actually provide the model to make the year, because this is where this one, when it's constructed. So when you're trying to create a class, this is the only function that's going to be executed when it's created. And then later on, if you call this function, it's going to access all the attribute information, because when you create it, you already assign those values. So later on, I can use it. Understand? So you can use it in all the functions, all the methods within this class. And yeah, try to like practice and look through that. Again, you can have as many functions within the class. Depends on how complicated you want your package to be. But you can only have one underscore in it. Okay, you cannot have multiple. So if you need to do additional stuff, you want to do it in here. So this is how you can create the function, and then you can modify the all the attributes are modifiable. Modifiable means that you want to allow the user to make changes. So for example, they create a car, and then maybe you randomly you change the odometer, or you do something, it's going to change the value. So this is how you can do that. Also, sometimes if you really want to like hide the attribute, so let me show you this one here, just to show you, right? I have this one now. My new car dot, and it's going to show you here the make, the model, the odometer, the odometer reading, and also the attribute. But for this one, probably you don't want the user to change, right? So for example, when you buy the car, the manufacturer usually don't want you to manually reset the odometer, right? Because you put on like 100,000 miles on that. You don't want someone to like change your car back to like 10,000. So this is where usually it's not, you don't want to do that. So in your program, you can either like have the attribute that don't allow the user to change, or you can do it this way. You can have an underscore, and if you have an underscore in front of the attribute, that means by default it's going to be hidden. So when you type dot, usually it will not show up. So let me show you here. Oh, I think it's being used somewhere. Let me remove this one. Don't read the odometer. Okay, so here my new car dot, you see, it's gone. Right? So if you have an underscore something here, by default it's not going to show up in this ID tools. But if I type dot underscore, you see this is more like hidden. If you want to have something hidden, usually put an underscore at the beginning of your attribute. So in that way, you don't have too many, for example, or you don't want by default you don't want to use actually to do anything in there. Then you can do it like this way. But still, this is changeable. This is still mutable. But I can do it this, and I can say 3, and you print out my car. Oh, you don't need to print out. So my new car dot read odometer underscore. You see, it's going to be 3. So functions, classes, attributes, these are all very important. You can modify the values. So make sure that you practice. This can get very complicated. It can get very, very long. So if you really want to see, like for example, just leaf map, I can show you what it looks like, the leaf map. And then within this one single module, and look at here, I just have one single class, and that class can inherit from another class. So this is how you can build on top of others. And this is what we're going to cover in the next couple of weeks to show you how you can build on top of other open source packages. If that package has a class, you can build on top of that. So by default, if you just have a parenthesis, that means you're going to build by yourself from scratch. But if you want to build on top of something else, you can do that. And take a look at this one. See how long is this class, right? I have some functions in here, and I have just one init function. This is just one, and see how long it is. And after that, you have all kind of functions. One function, second function, third function. See? It can go very long. Like how many? 4,000 lines. So within that class depends on how complicated, what kind of functionality you have. But you need to have an init function, and then after that, you can build all kind of stuff. You can add a bunch of functions, and this is where it becomes at the end. After you build the package, and this is where you're going to show up on the right here. And so when people, for example, the map, I have a function called add XSP, right? So you can allow the user to add a swap file to the map, and user only need to provide the URL to the swap file, and then everything else might use the default. And if you want, you can look at, for example, what kind of source code is in there. Right, self, that means it's the object, so you can call the object to do all kind of stuff. And functions you can call functions within the class, so it doesn't have to be everything on your own. You can build on top of others. So you can build on top of a class, you can build on top of a function, a method, or attribute, and this is how you can pass information within itself. So that for example, the robot can do things based on the instruction that you give to you. Okay, so it looks like we're out of time, but again, make sure that you practice, and this is what you're gonna get. And so next week, we're gonna quickly go through the files handling exception, and this is another important topic. So we're gonna spend maybe half the lecture when we come back from the break, and then we can start building packages. Okay, questions, Michael?
Quick comment. The environment and sustainability career mingle is happening starting now. There's free lunch. It's over in the Student Union Building, room 270.